Alright, folks, sorry for that disruption there. I think I've solved my technology issue. Where we left off, we were distributing our two terms there. So, R naught t was left untouched, and we had noted we could distribute this part of the expression into that part of the expression, leaving us with R naught, or RT, or S naught R naught, or S naught t. Again, just distributing each portion of that first expression to each portion of the next expression. Though not immediately simplifying my expression, it does allow me to apply some other theorems to it. For reference, we were distributing here, as this would be 15. And now as we continue, oh, and you should note, if you're looking at the key in here, the key has some errors in it. So, take that with a grain of salt. The key has a few minor issues. So now if you're looking in here, right, R and R naught, well, that would become 0. R and R naught becoming 0, well, that is theorem number 4. R naught t remains untouched, and we can't use this expression elsewhere, or this theorem elsewhere in here, so that's the only thing we can achieve with that one. Now, another thing we know is that anything ORed with 0 is 0, so it just goes away. So number 5 just lets us rewrite this without that 0 in there. Now, I'm not going to require you to write the theorems that you're using when you're working these problems, but I will tell you it's always the right choice to do so. If you are working these problems and you're doing this as you go, and you get stuck, when you come for help, you are going to get help right away. If not, I'm probably going to ask you to go back and label the theorems you did. I'm doing this for 2 reasons. One, if I ask you to go back and label the theorems you used, it's going to help me help you troubleshoot your problem. The other thing is, 75 to 80% of the time, if I have you go rewrite the theorems you used, you're going to see the place where you made your mistake. So save us both time, and write your theorems as you work your way through your problems. All right, now just looking at this, one thing I can notice here is I can rearrange my expressions. I'm going to do that right now. Because I noticed that 3 of them just have a standard t in them, and that might help me out. Now, let's see, I think my thing that would allow me to rearrange would probably be number 11. And now, oh yeah, don't let me forget, my S naught R is still there. I just moved it all the way to the right, just to help us see something. One thing I can see here is that t is in all 3 of these expressions. So I can have R naught, or R, or S naught, ended with t right there. And then my S naught R remains there. Let's see, I suppose this would be a distributive law in that I can remove something this way. And so now, working from here, I'm going to go and I'm going to look for a few things, right? Anytime I OR x with x naught, I get 1. And here I see R naught or R. So I'll get 1 if I apply my theorem number 8. So here's t. R naught or R just becomes 1. 1 or S naught plus S naught R. And that was theorem number 8. Well, now, I also noticed that anything ORed with 1 is 1. So I can just turn that into t of 1 plus S naught R, because anything ORed with 1 is 1, and it just goes away. That's number 6 that I'm applying right there. Oh, and then anything ANDed with 1 is just whatever it was. So t and 1 is just t. That's number 2. And I can follow my rule of once I've gotten to the point where I have essentially only one representation of each letter or 2, I'm probably done. I don't really see what I could do to make this any simpler. So with that in mind, we are going to stop. Oh, wait, no, I have one more to go. Excuse me. I'm just going to double check something quick. Okay. I knew something seemed fishy here. I noticed in my first expression I had taken S naught R naught, and I had forgotten to carry that R naught all the way through. This is one of the reasons you should always go back and look at the start. Is I was like, boy, where did S naught R come from? That S naught R wasn't in my original expression. It's because it wasn't. I had made a mistake. So right there we have T or S naught R naught. So don't mind me, that's my bad, guys, but it's a great example of everyone makes mistakes and we should always go back and check our work. With that in mind, we are going to continue checking out some of these theorems. The next one we are going to check out is this one. Our expression is PS or PQ naught S naught or PQS. And so this one is going to work kind of like that other one in that I'm looking for areas where I can easily extract portions of expressions. Now, this one is not going to jump out at you as immediately, probably, in terms of what to do with it. This one's a stinker. This is where you start to look at it and say, like, well, Boolean algebra has a lot of different things you could do, and sometimes you're going to make a move that seems like the right move, but it might not help you. So the first thing I'm going to do is I'm going to try this. I'm going to take P, and then S or Q naught S naught or QS. Alright, so that's the very first thing I've done there. Now, as I look through this, I'm going to start being like, well, what can I do with some of this? Ooh, 1 second, I got to plug in my headset. Okay, we're back. And now as we're working our way through this, one thing I do is, if you're ever stuck, you can start looking through for where is something that I do see. And sometimes you start looking for, like, whenever you have your S or something else that has that S naught, we're looking towards these consensus theorems to see if there's a way to use one of the consensus theorems over here. So I'd be looking and I'd be like, all right, well, here I have one that says X or X naught Y naught is equal to X or Y naught. Here I see S or Q naught S naught, so that's the same format overall. It's just different letters. What that lets me do then is say P, and then this one would have said S or X or X or X naught Y naught becomes X or Y naught. Now this would say S or Q naught S naught becomes S or Q naught. Alright, and so then that was our consensus theorem. That would have been, well, one of the ones around 16. This is where, like, you're not trying to be too specific with your theorem so much as you are trying to make sure that someone could go and trace your steps back just to make our lives a little easier. Alright, as we keep looking at these, I'm not really seeing a logical one. Oh, hold on. Well, here's Q naught or QS. Is that one? Yeah, I see another one right there. Another consensus theorem looks like it could be applied. Here's X naught or XY. Here I have Q naught or QS. So I can probably apply it here. There's only going to be one way we find out. This was Q naught or QY becomes X naught or Y. So this would be Q naught becomes Q naught or S. Then I'm not really seeing, I see S or Q naught or S. And one thing I know is anything, I can rearrange this. So hold on real quick. Let me say this was another number, we'll call it number 17. It was just another consensus theorem that got us there. And so now one thing we can do is we can commutate and move things around, move our order around. So I'm going to say P, Q naught or S or S. Then the next thing we can do is, I know anything ordered with itself just becomes itself again. And so that would be number 7 says anything ordered with itself is itself. So S or S is just S. Here's P, Q naught or S. S or S went away. Now, the last thing I can do is I can say, well, anytime I'm down to just like one of each letter, I'm probably done. I'm just going to rearrange this to put it in the format I like to see more. Here's P, Q naught, or PS. And that would have just been I'd just be distributing that out. So that's like a number 16 to redistribute that. Now, if you follow along in the PowerPoint, you're going to notice they did this a little differently than I did. That's in part because there's more than one way to work your way through an algebra problem. There's more than one way to work your way through a Boolean algebra problem. I recommend, honestly, as you are working this assignment, if you are stuck and you think you're done, go look at the key. Don't wait till you're done with the whole thing. Sometimes it just makes sense on this one to go and check your key after you're kind of done with each portion. So finish a couple problems, check the key to see where you're at. Finish a couple problems, check the key to see where you're at. This stuff is complicated, but if you just kind of think of it as a puzzle you're working on solving, I think that really makes a difference. All right, please let me know if you have any questions.